maybe you guys are all the audience that shows my previous video. So okay, let's go continue this question. So here I'm gonna use the blue color for bromine group here, and then for hydrogen it's here in the right side, and then phenyl group in the top side, and then in the back side here we have this hydrogen. Okay, using purple color hydrogen, and then here we have methyl group and phenyl group here. So for elimination reaction to occur, this anti-configuration bromine with hydrogen should the one that we need to have. Meanwhile here, this is not hydrogen. Where is the hydrogen? This is the hydrogen, and according to the bromine, which configuration is it? It is syn configuration. That's why it's not preferred. That's why each of the atom must move, must rotate, so then we can have the anti-configuration. Okay, for this example, I will rotate this carbon, so then bromine can be positioned here, and the hydrogen will be here, phenyl group will be here, and with that we can have anti-configuration between bromine and the proton in the carbon backside. So let's redo this. Okay, maybe better this side. So here, okay, I think better here. And then again with the blue color. So bromine now in this side, and then hydrogen now in the top side, and phenyl group in this left side, and the back side remain the same. Like this is the methyl group, and this position is right, the hydrogen, and this position is the phenyl group. Now we can have the bromine and hydrogen in the next carbon are in anti-configuration. Thus, this is the elimination process, the configuration that is the most preferred for the elimination process, which is the anti-configuration. Yay, this is the anti-configuration. So how should we draw? We can draw it like this, and then like this. Okay, now bromine, this is the phenyl group, and then here we have the bromine, phenyl group, bromine, and then this is the hydrogen, and then here we have still the methyl group, and then here we have the hydrogen and this phenyl group. Okay, so now this bromine and hydrogen are in anti-configuration. What else gonna happen for the elimination reaction? Remember, there is a base that acts as the nucleophile, and this one attacking the proton. Thus the electron will move to form the double bond, and it then suppress the bromine to leave the moieties. And this is how the elimination proceeds in one-step reaction. So now we have this double bond, which this is the proton, this is the phenyl group, this is the phenyl group, and this is the methyl group. Which this configuration, how do you say? Is this cis or trans? Cis or trans? This is no, this is cis configuration, girls, boys. This is the cis configuration, okay? Not trans, because here we have the heavy group in the same side, which is phenyl in the same side. That's why this is cis. Okay, so now we already have the answer for this question, like draw the structure of the main product of the ET reaction. Okay, so this is the main product, the molecule, double bond here. And then another last question is to also clearly draw which is obtained, which isomerism it is. And here we also have it, which is the cis configuration. We do not produce the trans configuration here due to the anti-enzyme configuration preference for the elimination reaction. So okay, it's already the answer. The answer is this structure. Congratulations with cis configuration. Yay. Okay, now it's done. Thank you for watching. Thank you for studying with me. Bye bye.